Okay, so welcome everyone. So here we are again together with another wonderful question based on number system and a very important concept of base system. So there are various bases. Some of the students get confused in the different kind of base systems. What is that base system? And there was a time that Cat used to use the topic of base system regularly. So, but still you find the questions on base system at various places in various competitive exams. So, we are here with one wonderful question. So, as usual, you are going to have certain time. You can pause your video or take a screenshot and first try to solve this question on your own. After that, we shall discuss it together. And your time starts now. Okay. So I hope you have solved it. और अगर नहीं solve किया है तो stop here, go back and solve the question. Try to solve the question. जितना time लगे लगाओ, but solve the question, reach to the answer of the question, right? Anyway, so let's start discussing now. It says Rohan wrote a program on his computer to generate and display the binary equivalents. Now, what is this binary equivalents? It is base 2, right? Base 2. You remember when we write any number in binary or base 2, we are using only 2 digits. Basically, that was the meaning of binary. Binary means bi refers to 2, right? So, we use only 2 different symbols or digits to write all the numbers. And what are the 2 different numbers we use in binary system? That is 0 and 1, right? We replace, we convert all the numbers which we are using generally in only 2 numbers, that is 0 and 1. So, every number can be written in the format of 0 and 1, 0 and 1, that's it. So that's how this person Rohan, a programmer, is writing a program to write all these numbers, binary equivalents of all the first n natural numbers. First n natural numbers, that means starting from 1, 2, 3 and so on up to a certain number. So if a total of 192 ones were displayed in the output of the program, find n. So basically, we need to find out total how many numbers he have converted or displayed in this binary equivalent values. And while doing this, he has used exactly 192 ones, right? 192 times he has used the letter or digit 1, right? So, kitne numbers se, that's what we have to find out. So, how we can find out that? So, the pattern is a very important word, right? Pattern is a very important word, and it may be tricky also if you are unable to see the pattern. And for those who are curious, who have got special sense of sensing the patterns, that must be really enjoyable thing for them, right? But let's try to see. Patterns exist all around us. All around us patterns exist. So we need to be vigilant to find out, right? Okay, so let's see what pattern would be there. So here, I hope all of you know how to convert a number from natural numbers of base 10 to binary numbers, right? So let's write a few numbers first. So if I'm writing only single digit numbers, let's say 1. So 1, when you write in binary, it is 1 only, right? 1, when you write in binary, it is 1 only. But 2, when you write 2 in binary, so when you write 2 in binary, it becomes a 2-digit number, right? So it is written as 10, something like this. It is 10, right? Now in base 10 we use it for ones place, then tens place, right? And in binary it is ones place and twos place, then 2 squares place, then 2 cubes place and so on. So like that, this is ones place and this is twos place. So this is 1, 2 and 0, 1. So it is 2, right? This is binary. Same way when we write 3, it comes out to be 1, 1. Right? Now this is 1, 2, this is a group of 2 and this is single number. So 2 plus 1, this is 3 basically. So when we write 4, it comes out to be 3-digit number because there are no 1s, there are no 2s, this is simply 4s. So this is 1 group of 4 and 0 group of 2s and 0 group of 1s, like that. So that's how you can convert all the numbers in binary. But are we going to write all the such numbers in that way? Certainly not. So 1, 0, 1 is the next number, 6 we would be writing in that way, 1, 1, 0, isn't it? And after that 7 would be 1, 1, 1. You can check also, as I was telling you, this is a group of 4, that is 4, 1 group of 4, 1 group of 2, so 4 plus 2, that makes it 6. And this is 1 group of 4, 1 group of 2 and 1 single one, right? So 4 plus 2 plus 1, that is 7. So these are all 3-digit numbers. So if I check the pattern, so till 1-digit number, I wrote only 1-digit number. So how many ones I had used here? How many ones I had used here? Only 1, right? Only 1. So now if I talk about up to all 2-digit numbers, when I'm using all the up to 2-digit numbers, so total how many times 1 we have used here? So 1, then 2, 3, 4, it is 4. You can see this, right? And when I have written all the numbers till all the 3-digit numbers, because after that when I'm writing 8, it will become a 4-digit number, because this is the largest 3-digit number I can write in this binary equivalent. So up to 3-digit numbers when I'm writing, so total how many times the digit 1 has been used. So it has been 4 so far. After that 5, 6, 7, 8, 9, 10, 11 and 12. So this becomes 12. Are you able to sense any pattern so far? It looks typical. Let's proceed one step ahead. By the way, I can suggest you something. This is multiple of 1, right? We are talking about till 1-digit number only. This is multiple of 2. This number is multiple of 2. We were talking about numbers till 2-digit numbers, right, in binary. And because here we were talking about the 3-digit numbers in binary, so this term is multiple of 3. So it appears that the next term, when we go up to the 4-digit number, it must be multiple of 4. Let's check out and confirm the pattern first, right? Let's confirm the pattern first. So when I'm talking about the 4-digit numbers also, so first tell me how many 4-digit numbers would be formed. Can you suggest something? How many 4-digit numbers would be formed? You can see among 1-digit number we are not using 0, so it's only one number. In 2-digit numbers we got 4 numbers. In this 3-digit numbers we got 4 numbers here. This was 2 numbers. There are 4 numbers. So 2, 4, and this would be 8. Yes, it is going to be 8 numbers. So 1 number, 2 number, 4 number, and this is going to be 8. You have seen that number of numbers are becoming doubled, right? Number of numbers are becoming doubled. पहले एक ही number था, अब 2 number आ गए, अब ये 4 number आ गए, and there are going to be 8 numbers. So how this is going to be 8 numbers? That's very easy to write. So this 8 is the first number. Now first place will be filled by 1. Now this first place refers here, which we call basically thousands place. Here it is 8th place, right? So there's one group of 8 and no group of 4s, no group of 2s, and no single ones, right? So that is the smallest number, 8, which is having 4-digit in binary equivalent. Same way when you look for 9, so we are going to have one bundle of 9, one group of 9 and one group of 1, right? So there are no groups of 4, no groups of 2s. So that is same way place value used in normal base 10, same way we are using in binary, and same is applicable basically for all base systems. That's why I'm extending them. That's why I'm saying that all the questions which we are discussing in this series, we are not discussing single question, we are discussing a concept, and that is going to be extended to any extent, right? That can be extended to any extent. Okay, let's move further fast. So 10 would be what? So 10 would be having one group of 8 and one group of 2, right? So that is 10. Okay. Okay, so moving further, what about 11? So it is going to be one group of 8 and 2, 10 and 1, 11. It's 1, 0, 1, 1. And you can see the pattern, increasing pattern as well. So the next number would be 12. That is one group of 8 and one group of 4, right? 1, 1, 0, 0. After that, you are having 1, 1, 0, 1. Then 14 would be 1, 1, 1, 0. And finally, 15 would be the largest 4-digit number in base 2 or binary. That is 1, 1, 1, 1, right? That is 8 plus 4, 12 and 2, 14 and 1, 15. Fine. So basically we have already identified there are going to be total 8 numbers. Now continuing with our pattern, so if I include all the numbers till 4-digit numbers in binary, so what will be the total number of ones? See, so far we have used 12 here, right? 12 के बाद let's add further. So 12 के बाद this is 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. This comes out to be 32. Including that part, this comes out to be 32. Right? Now let's try to observe the pattern. I was telling you this is multiple of 1, this is multiple of 2, this is multiple of 3, this is multiple of 4, right? This is multiple of 4. So what else can we further clarify this? Let's see. So I'm writing these parts here. So this 1 was 1 only. This was 1 into basically 2 power 0. Right? I can write it like that. This is 1 into 2 power 0. And what about this 4? This 4 is basically 2 into 2 power 1. Right? This was 2 into 2 power 1. And this 12 is basically 3 into 2 power 2, isn't it? And same way this 32 is basically 4 into 2 power 3. Yes or no? I hope this pattern is clear to you now. Here we had used the digits up to all the 4-digit numbers in binary. So this 4 is the first part into 2 raised to power that 4 minus 1. So that is the general pattern now. So in general, what I can say, if I'm writing, now that's my conclusion of this, observing this, after observing this pattern here, if I write all the numbers from 1 to 2 raised to power n in binary, right? If I write these numbers in binary format, so how many ones would be used? You can see that this 2 power n would be a n plus 1 digit number, right? Let's say इसको हम 2 power n minus 1 तक की ही बात करते हैं, right? 2 power n minus 1 तक की बात करते हैं. So this is going to be numbers up to n digit number, right? This will be the largest n digit number. So how many times the digit 1 would be used? It is going to be n into 2 raised to power n minus 1. So that is the conclusion here. So when we write all natural numbers from 1 up to 2 power n minus 1, then how many times the digit 1 would be written here? It is going to be n times 2 raised to power n minus 1. That's it. That's the net conclusion. Now in this question, it is given that this total number of ones, if a total of 192 ones were displayed in this output of program, find the value of n. So we need to find out that last number. What was that last number? If this total of 192 ones have been written. Let's identify 192. So 192, does it fit this category or not? Let's see. So 192, if you factorize, 192 if you factorize, it would be how much? If I put n is equal to, it is not certainly multiple of 5. We can see it is not necessary that we have written all the numbers till 2 raised to power n minus 1. They may have used a lesser number. So basically, I am trying to identify that number which is of this format. It may be 192 or it may be less than that. After that, we can further count, right? So if I use for a number, let's say 5. अगर 5 तक की हम बात करते हैं, so 5 into 2 power 4, that is 16 into 5, 80. That would be a smaller number. So up till it's not 5 digit number, it's further increasing. So अगर मैं 6 तक की बात करता हूँ, तो this would be 6 times 2 raised to power 5, right? Now 2 power 5 is how much? This is 32, and 32 into 6, how much it is? So 32 into 6, 32 into 2 is 64, 64 into 3 is 192. Yes, it satisfies. That means we have got it. We have got it. So basically this n is nothing but 6 here, right? This is 6 times 2 power 5, which suggests that what is fine, na? Yes. So what numbers we have used basically? कहाँ तक ये? This is not 2 power n minus 1. Let me correct it. This was not 2 power n minus 1. It was a number one short of that. It is not 2 power n minus 1. It is basically 2 power n minus 1. It is basically 2 power n minus 1, like that. Right? So when we are, this is 2 power n minus 1 is the largest n digit number here, right? So in this case, 2 power 5, that is 32 minus 1, 31 is the largest 6 digit number. So 192 ones would be used obviously from starting from 1 up to 1, 1, 1, 1, 1. 1, 2, 3, 4, 5 and one more time, 6 times 1, right? So this is the largest 6 digit number, which is basically 31. We are talking about the 6 digit numbers. Yes, we are talking about the 6 digit numbers, and among the 6 digit numbers, this is the largest one. This is the largest one. So we have used all the 6 digit numbers, and this is the last number we are using it. So when we have used all the numbers starting from single digit number 1 up to the 6 digit numbers, whose the last number, the largest number is 1, 1, 1, 1, 1, 1. That is the last such number. So till that point, so we have used exactly 192 ones, right? So this is suggested by this pattern here. The pattern we have already observed from here, right? Pattern we have already observed from here. So that's the whole thing. That's it. So what is that largest number? What is the value of this number? Now you can check out very easily. So or you can identify it with the pattern also. So this is a number of 6 digits. So this number is nothing but 2 power 6 minus 1, as we had done here as well. So in this case, you can equate here. So n minus 1 is equal to 5, which means n is equal to 6. Which means n is equal to 6, right? N is equal to 6 here. It is suggested directly from here as well. N is equal to 6. So n is equal to 6 means what is that last number? So n is equal to 6 suggests that 2 power 6 minus 1. So basically in this question, where it writes this number n, so this n here is this 2 power 6 minus 1. Now what is 2 power 6, students? 2 power 6 is 64, right? So this is 64 minus 1, which is 63. That's it. Okay, so this is our answer. Option A is our answer here. That's it. Okay, so as I suggested earlier that this is not a single question we are dealing the family of question. See, in this question, in place of binary, if it becomes base 3 or base 4 or base 5 or whatever base, this pattern which we have observed here, that will always be followed. That pattern will always be followed. So in place of 2, if it is some other base, right, if it is some other base, still you are going to get the same pattern, that till that number, till the last number of that many digits in that base, when you are converting, so how many times the digit 1 would be used, that will always be given by this part, right? So that many times the digit 1 would be used. So that was the answer to this question. So answer here is 63. So exactly we have written all the numbers from 1 to 63 in binary, and that's how we got exactly 192 ones. Okay, so I hope you have understood, and certainly you may need to revise this whole video once again to understand the concept thoroughly, right? So thank you very much, and we shall see you once again in another question in another session. Thank you.